Okay, so now we got to try to figure out why.
There's only one way.
So if we can figure out why there's only one way,
then we'll have our answer.
then we'll have our answer. And our answer will be, there will be
White.
one white cube left.
Alright. So... well...
And we certainly can't check all of the possible ways to work this out.
No. No,
There's tons of those.
we cannot. check
Well-
all those ways.
what might happen is you might... so if you sort of... you can't really get rid of the whites.
What do you mean?
So you have an odd number of... well, so you have an odd number of whites. So if you started by getting the whites down, you'd be left with one.
Okay.
And you just add to your black
You'd add to
total.
and then if you decided to get rid of that, if you pair it with the white with the black, then you get a white again.
All right.
So in the blacks, you can get down really easily. They just sort of divide down to one.
Okay.
So that makes me think that the end scenario I might always be one white and one black, which will lead to this white thing.
Okay.
White end.
That's a very interesting idea. What do you think?
Well, I think that makes sense because if you have an odd number of whites like you have here, you can whittle them down with using this rule. That'll get you to one white.
Okay.
And then that'll add, I think, 11 onto the blacks. And then the blacks, it's slightly more complicated, but you'll still just whittle down to one.
Okay.
And then you'll be left, but you don't change the white anymore. So you'll just be left with one white and one black.
Okay.
Can't really get rid of the whites.
Can't really get rid of the whites. So look at the table we made here with 2 and 3.
Well,
Does it conform to what your strategy is? So what is your hypothesis now about how this game works?
so the end scenario will be one black and one white, which will lead to be a white.
Well, that's the specific game. How do you think the game works in general?
So you can get the yellows down. If you get the yellows down to one, then you can't really do anything else. You have to whittle the blacks down to one too,
Okay.
and then you do this black whites to get to one.
What's your hypothesis for how the game works?
That's just my hypothesis.
Okay. So tell me in a general starting position, not the one we have here, but in a general starting position, how are you going to determine whether you end with a white or a black?
So in a general starting position, we can start by whittling down the whites.
Okay.
Well, but if there's a power of 2, well,
Well, if there's just an even number of whites, then that'll leave us with 0 whites.
Okay.
But there's an odd number of whites, we'll have 1 white left.
All right.
So that means if there's an even number, there's the black will be the last bead.
Even number of
Even number of whites.
Even number of whites. Black will be last.
Black will be, and then an odd number of whites.
White.
White will be the last.
Okay. Does that work with what we found with the 2s and 3s?
Yeah,
Yeah.
because if there's an even number, then
As
you
in
can get
here and here.
It's an even number of whites, and you could get rid of them, and then you'll be left with this black.
Okay. And what about when there was an odd? Did it work?
Yep.
Yeah.
White and white and white.
Okay.
Yeah.
Good. So let's just do one last video and I'll show you sort of how to prove this.
Alright.
Alright.
Okay.